Today we're going to talk about basic probability. Probability is roughly defined as the likelihood that something will occur. So let's look at some situations. The first one, if there are two children in a family, the possibilities are two girls, a girl and then a boy and then a girl, or two boys. Knowing this, we can answer some questions. What is the probability that there is exactly one girl? If we look at this is not exactly one girl. That's exactly one girl. That's exactly one girl, and that is not. So the probability that there is exactly one girl is 2 out of the 1, 2, 3, 4 possibilities. Lowest terms for that would be 1/2. The probability that there is at least one girl, well, 2 girls is at least one girl. That's at least one girl, and that is also at least one girl. So there are 3 of the 4 possibilities showing at least one girl. So this is an example of if you're given the entire set of possibilities, then counting the things that will be successes and putting that in a fraction over the number of possibilities is the answer to our probability question. Okay, lots of probability surrounds sort of things that happen with a deck of playing cards. So if you're not familiar with a 52 card deck, there are 4 suits: hearts, diamonds, clubs, and spades. And each suit has an ace, which often counts as 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, and then a jack, a queen, and a king. So there are 13 cards in each suit. 13 times 4, 52 cards altogether. So what is the probability that if someone took that deck, they would deal you the 3 of hearts? Well, there is only one 3 of hearts out of 52 cards. So you stand a 1 in 52 chance of being dealt the 3 of hearts. Okay, what is the probability you are dealt a 3? Well, there is a 3 of hearts, there is a 3 of diamonds, there is a 3 of clubs, and there is a 3 of spades. So there are 4 out of 52 cards that are 3s. And in lowest terms, that's 1 out of 13. What is the probability you are dealt a 3 or a heart? So there's the 3 of hearts, the 3 of diamonds, the 3 of clubs, and the 3 of spades. So there are 4 of those. And there are the hearts. There's an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, and a king. So it appears as though there are 13 hearts. But if you watched carefully, you counted the 3 of hearts, or I counted the 3 of hearts twice. I counted it as a 3, and I also counted it as a heart. So if it's already been counted here, there are only 12 other hearts. So out of the 52 cards. So we actually have 16 out of 52 cards that are either a 3 or a heart. Divide by 4, so we'd get 4 out of 13. The probability you are dealt a card that is not a face card. Now the face cards are the cards that have people on them, the jacks, the queens, the kings. So if it's not a face card, it would either be an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, or a 10, and there are 4 of each of those. So 40 out of 52 are not face cards. By 4 would be 10 out of 13. The probability that the card is not a 2. Well, if there are 4 2s, like there are 4 3s, then the ones that are not 2s would be 48, because 52 minus 4 is 48. So that would be 12 out of 13. So there's some card probability. 2 dice probability. Okay, so single die could come up 1, 2, 3, 4, 5, or 6. And the other die could come up 1, 2, 3, 4, 5, or 6. And the easiest way to answer dice problems, 2 dice problems, is to make what we call a dice chart. So if you rolled a 1 with a 1, you would have a sum of 2. A 1 with a 2 would be a sum of 3, 4, 5, 6, 7. If you rolled a 2 with a 1, that would be 3. A 2 with a 2, 4, 5, 6, 7, 8. A 3 with a 1, a 3 with a 2, 3 with a 3, etc. And this fills in pretty quickly. And if you have a couple of questions to answer, it's worth doing. And we do have a couple of questions to answer. So, the probability that you roll a sum of 3. Well, what I filled in here were all the possibilities. And there are, let's see, 6, 12, 18, 24, 30, 36 possibilities. And 2 of them are showing a sum of 3. A sum less than 5. Okay, well, there are the 5s. So the 4s, the 3s, and the 2. So 1, 2, 3, 4, 5, 6. 6 out of 36 are less than 5. A sum of 7 or 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 36, or 1/4. Hopefully you can see the value of having the chart, because then we're just counting up the possibilities that meet our criteria. Okay, so in a bag there are 5 green blocks and 7 red blocks. What's the probability you pull a green block? Well, there are 12 blocks altogether. So if I'm reaching in to pull out a block and 5 of them are green, it would make sense that I have a 5 in 12 chance of pulling a green one. The probability of pulling 2 green blocks in a row, well, the probability that the first one out is a green is 5 out of 12. But if we think about this, let's see, 5 green, 1, 2, 3, 4, 5, and 7 red, 1, 2, 3, 4, 5, 6, 7. Okay, so the probability that I pulled a green block in my first pull out of this bag was 5 out of 7. And we're going to pull again out of the bag. And usually with block problems, the phrase is without replacement. So I would have had to have pulled one of the green blocks out the first time in order to go on. Because if I hadn't, I wouldn't be going on. If I had pulled a red block first, there was no way to pull 2 greens in a row. So we look at the probability of pulling a green out first and then say, okay, we have to go forward, but we're only going to go forward if one of the greens is now missing. So now we only have 11 blocks in the bag because we assume that one of them came out, and only 1, 2, 3, 4 of them are green. This is called an event that is dependent. So this second pull is dependent on what happened the first time around. So that's 20 over 132. Probably best to simplify the problem. So that's 5 out of 33. So probably we pull 3 reds in a row. Okay, well, we go back to the original bag. The probability that I pull a red out the first time is 7 out of 12. In order to go on, I have to assume I did pull a red. So now there are only 11 blocks in the bag, and only 6 of them are red. Now, in order to pull a third block, I have to assume that I pulled a red block the second time, so there are only 10 blocks in the bag, and only 5 of them are red. And again, probably easiest to simplify the problem. So this is 7 out of 44. I want to contrast that with a problem about a spinner. Okay, so here I have a spinner. Oops. Here I have a spinner. There it goes. It's spinning around. We can see that 2 of the sections are red and 4 of the sections are green. The probability that I will, on any random spin a green would be 4 out of 6 because 4 of the 6 sections are green. So that's 2/3. The probability that I would spin 2 greens in a row, well, the probability I spin a green is 4 out of 6. But now, the probability that I spin a green the next time is not dependent on whether I spun a green the first time. The spinner doesn't change. It's still 4 out of 6. So that would be 2/3 times 2/3, 4/9. The probability to spin 3 reds in a row, well, there's a 2 out of 6 chance that I spin a red the first time. And the spinner, unlike the bag, doesn't change in between. So I still have a 2 out of 6 chance of spinning a red the next time. And a 2 out of 6 chance of spinning a red the third time. That's 1/3 times 1/3 times 1/3, or 1/27. Okay. Let's take a look at a problem where someone has gathered data. So we have, according to this, 21 freshmen playing sports and 12 not playing sports, 27 sophomores playing sports and 10 not. I'm making this data up. 28 and 6, 15 and 17 for seniors. Whenever you do table probabilities, make sure that you have some totals. So the total number of freshmen was 33, the total number of sophomores was 37, 34 juniors, and 32 seniors. The total number of people playing sports, 91. The total number of people not playing sports, 45. This is 136. It is also 136, pardon me, pardon me, if you add up the number of students. So the probability that I choose someone at random and they play a sport, that would be 91 out of 136. The probability that I choose a sophomore and she does not play sports, well, let's see. Of my 136 people, the ones that are sophomores and do not play sports is 10, which can be reduced, but I'm going to try and save a little time here. The probability that it's a senior or she plays sports, I'm going to look at it this way. It's like these are the play sports, and these are the seniors. Notice that the seniors who play sports are sort of in both categories. So what I'm going to do is I'm going to take 91, because that's all the people who play sports, and then add in the seniors who do not play sports, because then we'd have all the people who play sports or they're seniors. So that would be 91 plus 17, which would be 108 out of 136. Again, I could reduce that to lowest terms. Okay, try some probability, see how it goes.